Hello everyone. We have a new video today and it will be talking specifically about one of the physics quantities, which is the vectors. Now if we go step back, we know that in physics we have two types or two categories of quantities. One is the scalar quantity, which is representing certain quantities where it has only magnitude or size, such as a temperature, such as the length or the distance between two certain points. The other one, which is our video subject today, it's the vectors. And vectors in mathematics or physics, it's an object that have magnitude and the size and also have a direction. So it will be specify that this is how much is the vector magnitude or the size or this quantity size, and there is a specific direction this object moving toward or directed to certain point. So there are so many things related to this in the world of physics, such as when I say velocity. Velocity, it's different than speed. Speed is a scalar quantity, which is just the magnitude. I'm driving my car with a speed of 100 kilometer per hour, and that's it. Where velocity, it will has the magnitude, which is the 100 kilometer per hour, plus I will say my direction, which is north, off east to north, maybe something we could say like it's 30 degrees off north to west, something like this. So I will add to the magnitude value direction. We have forces, the gravity, acceleration, the electric field, magnetic field. There are many quantities in physics can be identified under a vector quantity. It has a magnitude and direction. Now, how we represent vectors, usually we can represent vectors as a kind of like it's a line. It's a segment line, have a tail and have a head, which is always have the arrow representing the direction of this vector. Now, let's say I'm drawing here a velocity vector. I will put the v, and usually we'll put a small arrow on top to say this is a vector quantity. Um, Vectors could be added, could be subtracted, could be multiplied. There are different ways to add vectors and also subtract them and analyze them. It depends on the scenario of the situation, and I will show you that very shortly. Now, one thing I will talk about it briefly. Let's assume I have a situation like here. This is a vector, and we'll say it's a velocity 1. Now, I draw an angle here. Let's assume, just call it theta, not necessarily what's the value. Now, we know this is east, this is north, west, south. I could describe this vector with, say, it's 100 kilometer per hour. I could describe my vector, it's 100 kilometer per hour off east to north, because the angle is located between the east and the vector direction. All right. Another example, we could, let's draw something different. We could say, all right, it's here, but I'll put the angle this time here. I call it alpha. In this scenario here, it's the vector name, whatever it is, with the magnitude, and I will say it's off north to west. So I just want to grab your attention to this way of writing or describing vector directions you might see in some textbook or other things. All right, now let's talk about how we can add vectors. So one of the techniques we could use, it's the parallelogram, which is simply it's we drawing and you using the ruler, but we have to have a scale. So let's say this vector here, Let's call it vector A. This is vector B, and I want to find their resultant. So A plus B, that's it here, and we call it the resultant. Okay. Now I could use the parallelogram method, but in this case I have to identify my vectors by scale. So we can say, all right, each square of or each centimeter of a vector represent, let's say, 15 Newton. And based on that, I'll draw my vectors. Now, to find the resultant in the parallelogram scenario, what I do, I will take vector B and I will draw a parallel one from the head of vector A. So here we go. And we have to keep the same length, the same direction. Same thing, I will go with the vector A, but I'll start from the top or the head of vector B, and I'll draw it parallel to vector A. So we could make this a bit longer to close the whole thing. Now, where is my resultant? The resultant will be, in this case, simply we start from the tail and we go to the head where the both vector met each other. That will be my resultant vector, which is the addition of vector A plus vector B. Now, as I said, we have a scale. So when you measure the scale, the length of your resultant vector, simply you can turn how many centimeters to the magnitude. Then you can find by the protractors what is the direction of your resultant. Same thing here with the next example. I could do that again. So I will be parallel for the orange vector, okay, and I will be a parallel here to the blue one. Now it's time for using the resultant. I'll start from the tail to the head, and that will be my resultant for these two vectors. Okay, this is the method of the parallelogram. The problem with it, you need to have graphing papers, you need a ruler and protractor, scale. It's not quite the way we use often. All right, now there is another way to help us dealing with adding vectors, but or finding the magnitude and directions and other stuff for the vectors, which is related to what we call it finding the vector components. Now, let's assume this is a vector representing the velocity and it is 100 meter per second. That's the magnitude of my velocity vectors. And it's making a 30 degrees angle with the horizontal or off east. Now I'm asking you to find the components of the vector v. Remember, this is the resultant vector. I need to find the component. Now, usually, this is the way we do vectors. It will have two components. One is the x component and one is the y component, or horizontal component and vertical component. So let's do that. So if I want to do the horizontal one, it will be this one here. That's it here. That will be, we call it Vx. And for the y component, it will be here. That is the y component of vector v. Now, to solve it and help us to figure out what is the value or the magnitude of the v component of the vertical direction and the x component of the velocity, what we do, I will just take the y component and let's close this a triangle. Now, from mathematical point of view, I can do this. Look how I can handle the scenario. Now, we said this is the Vy, this is the Vx, and this is the resultant. And here it is, my 30 degrees angle. Now we can follow the trigonometry's rules. Let's say I want to find the sine of 30 degrees. Now we know the rules of the sine, the meaning of the sine of any angle. It's the opposite over the hip. So it will be Vy over V. From here, I can say that's mean the y component will be the V sine 30, which means it's 100. That's the magnitude of the resultant times 0.5 sine 30. That will give me 50, and we have to give it a unit. It's a 50 meter per second. So that's the magnitude of the y component of this vector. Same thing. Let's go and say, all right, what about cosine 30 degrees? The cosine, it's the adjacent, which is the x component, over the hip, which is the v. From here, I will say, all right, the x component of this vector, or vx, it's going to be v cosine 30. Once again, it's 100 multiplied by 0.86, and that should give me, sorry, a second, let's calculate it quickly. Cosine multiplied by 100, that will be 86 meter per second. So this way, what we call it, finding the component of the vector, the horizontal component and the vertical component, it depends on the angle location. So we can identify which one gonna be the cosine, which one is gonna be the sine, based on the definition of the adjacent and the opposite. All right. Now in the next videos, I will try to practice with more examples how we can find the components of a vector, because it's the most popular one to use in the world of vectors and the motion into dimension. All right. I hope you find this video useful, and I'll see you again. Thank you.